Okie dokie dokie dokie. It is Wednesday, January 25th, 2017, and let's get the stream started for the day. Hello, everybody who may be hanging out, and hello to future people who are not hanging out yet, and future streamers who are watching the replay. Let's see. Feel free. Ask questions. I will be more than happy to try to help out as best as I can. The plan for today was on Monday, someone asked about setting up a basic like day-night event trigger. So you could think of it as my lights should shut off automatically during the day and my lights should turn on automatically at night. So kind of like a little event dispatcher type system. So the original plan was to use event dispatchers, maybe an object, and just have things register with it. But what I'm thinking is we'll show a few different ways of doing this. We'll show something storing references and then telling those things what to do, which is basically an event dispatcher system except hard-coded. And then we'll show how to do it in the event dispatcher. We'll maybe put it in its own blueprint, maybe put it in the game mode. I don't really know. But we'll just spend some time on this and try to get a nice little system that's portable and easy enough to just drop into a project and use. So let me make sure that everybody is working. I'm pretty sure everybody is. Let's see. Looks like everybody is. If I knew how to click on that one to make it work. Let's try this. It's one of those days. Everybody's sick. Yep, there we go. Cool. Looks like it's streaming. Was I smart enough? Yes, I was smart enough to change the tab. So we're good. Okay. So let's get right into this. If I can figure out where I put my stuff. What? That's not it. There we go. Okay. So I have a basic map here. It's just a third person. We're going to do this on the premise of lights, so let's just create a basic light. That's kind of a little bit required here because we don't have anything to turn on and off. So we'll do a little bit of setup here. Replace our default route with a default route. And we're going to need a light, but let's make it kind of like a generic lamppost. So what do we got? 0.1. I typed 0.1, but it didn't work. 0.1. 0.1 and 0.5. Go something like that. Let's see. Move it up a little bit off the ground. Grab a light. So we'll go with a point light. Put it in the scene like that. And that should work, right? We should be able to just drop that into the ground. Have ourselves a really short light. Let's make that taller. There we go. And then bring our actual light back up to the top, like that. Okay, that's a little bit better. I really hate how you can see the icons, but we have a light, and we can at least see that it is putting off light. Let's get that up a little bit. See if that helps a little bit. That'll work. Okay. So we have a basic light. I think we're going to do the method of registering with something first, not using event dispatchers, but basically using the fake event dispatcher way. And then we'll move on to doing it with event dispatchers. So we're going to need... So there's technically two ways of doing this. Well, there's a few ways of doing this. But we can have the light handle itself. So basically the light turns itself on and off. And it does it whenever it's supposed to. Or we could have something tell the light to turn on and off. Doing it the second way, where something tells it to do something... will work, but then you're kind of requiring something else to be in charge. If we just simply pass an event to this saying, hey, do something, and then this does it, it's probably easier. Then we keep all the logic contained in the light. So the light knows how to turn itself on and off, basically. So we'll just make two events. Let's see, this will cause a problem, and we're going to fix it because we're going to go about this the specific way, then the generic way, then the event dispatcher way. So handle light on. I'll do a custom event, handle light off. I'll just do that. And it should be pretty simple. Lights have, I don't really mess with lights, to be honest. Lights, it's pretty much just the intensity. That's the only way I'm going to be able to affect it, right? See, the cool thing about this is oh, you know what? Why not? I think that would be fun. Why don't we make this a really cool light? We'll do a timeline. Okay, if I can stop moving everything. There we go. And we'll do a little bit, we'll do a little 2-second lerp. Call this one a lerp 0 to 1. We'll add a few keys. Set our first key at 0, 0. This one's more just for aesthetics because I think it would be fun. And 1, 1. So we just have a basic lerp here. Let's name our timeline lerp 0 to 1 because that's what we're going to do. And all we're going to do is basically, instead of turning our light on or off instantly, we'll just move it over time. We'll just have it go from on to off over 2 seconds or off to on over 2 seconds. So it'll look kind of cool. So for point lights, let's move the point light up on top of the cube. That would be smarter because technically it's our child. So let's see. For point lights, that's probably going to be our intensity, right? If I can go back to here, grab our light. Yeah, it's going to be our intensity. So we'll keep that default of 5,000. Let's give ourselves a variable. We'll call it default intensity. That way we could technically have each of these have their own intensity value. Hello, learner man. Okay, so what we're going to do is we're going to, oops, grab up here, set intensity. Hook that up, move this. Okay, I apparently cannot aim today at all. And we're going to lerp. We're going to lerp a float. This should be in the alpha. And we're going to lerp, let's see. We're just going to copy paste these nodes rather than trying to duplicate. No, because technically, actually the handle light off would just be a reverse. So you know what, never mind. We can just use one node for this. We'll do this. Yeah, that'll work. So let's see. When we're going forwards, we're going to go from, let's see, light on. So we're going to go from nothing to our intensity. Like this. And then we're going to go off. We're going to go from our default intensity to the other one. Okay, there we go. So that should work. Let's just call this to test. We'll go ahead and tell this thing to play when we begin. That way we can test this. Let's see. Our light should have gone from, oh, probably, no, 0 to, yeah. Oh, yeah, no. Oh, did I not set, yeah, didn't set the default intensity. That would be helpful. There we go. So now the light should go from off to on. There we go. Cool. I just wanted the simple basics. It helps if we actually plugged everything in. Hello, James. So we have a default light. Now we should be able to turn it on and turn it off as we need to. Now we need some way for something to call this stuff. So again, like I mentioned, we're going to do this the fixed way, and then we're going to convert it into the more generic way. Because maybe you want... because the goal at the end of this is to basically have something that can generically handle time events. But we're going to do it in the way a normal person would probably do it. Go from fixed to flexible to generic. That way we can learn the entire process and why we do things. Right now it's fixed. Something has to tell this light to turn itself on or off. Yeah. So that's something in this case is going to be... See, the game mode would probably be the smart one to handle for this. This is not up. There. Oh, that's... Oh. I forgot to move the access point up. There we go. That would be why it looked weird. Okay, let's go back in here. There we go. Now it's out of the ground. Okay. So the we have our game mode, and our game mode is probably the smartest place to put this. It's a universal object inside of our level, and everything can get access to it. Everything can talk to our game mode, and our game mode can technically talk to anything if it's talked to it. The fixed version of this might be to have like an object we create, maybe like a light manager or a time of day manager. But that really makes it fixed, so we're just going to use the game mode, because the game mode's honestly where you're going to want to put this. Unless there's something you really need a specific object for. So we're going to do this in the game mode. Game mode. And the nice thing about this is it's really simple to set up. We'll turn this over to our time of day game mode. Right here. And we're going to just want to make sure we still use, let's see, our third-person controller and our default pawn third-person character. There we go. So now it should be the same as before, except we should have a time of day game mode. There we go. So we're good. So our game mode somehow needs to be able to keep track of the things it wants to do stuff with. So we're going to create an event in here. We're going to call this register for time change. We're going to call it register for time change. Again, we're going to make this very kind of flexible, and then we'll make it super generic. So it'll be called register for time change. And we're only going to allow actors to register for a time change. So where'd my stupid thing go? Here we go. So we need input of an actor. So this will be input actor. And we're going to call this an actor. And we need actor reference. So this way we're going to pass in basically who called us. Someone mentioned to me today something called get daytime string. Get daytime. Well, there's get time of day, but this is real-time information. So, for example, if I pull this out right now, it would show me 10:11. So it's 10:11 a.m. right now, my time. So if you want real-time stuff, then yeah, you have the nodes. You have the date and time nodes to give you real-time information. But that's not going to help if you want something less than real time. So that's something to keep in mind. And even if you did use the get time string, for example, or you got the real time stuff, you're still going to need to be able to handle things registering and unregistering. And that's the primary point of all this. So we're going to make a new array. We're going to call this registered actors. And we'll call this actor reference and make it an array. So this is where we're going to store all of our registered actors. These are the things that are going to we're going to want to do stuff with. So all we're going to do here is grab this. We're going to make sure it's add unique. That way, if somebody tries to register with us more than once, we basically don't have an issue with it. It'll only keep one entry in there. We don't want duplicate entries. Honestly, this is all you need to register for time change. We'll make another custom event called unregister. And the funny part is, anyone who knows what we're doing, this is all basically recreating an event dispatcher system. That's all this is. But this is how we learn. Input actor. It's going to be an actor. And then we'll basically grab our registered actors and we'll remove it. Remove the item, and we'll remove that actor. So this basically allows us to add the actors to a list and remove them from the list, so we can do stuff with them later. Let's go ahead and do that in our light. So when this begins play, basically we can have this technically on construct, but we'll do begin play. So when this actor exists, we're going to want to register with our game mode. Now at this point in time, we're going to fix this. This is going to be a static, not static, but this is going to be fixed. We're not going to make it generic yet. Again, we're going to show why we're doing everything. So we're going to get our game mode. We're, of course, going to have to cast it to our time of game mode. And we're going to register ourselves. So register for time change. Now, usually when you do something, you always want to make sure you balance it out. So since we're registering, we probably want to unregister ourselves when we no longer exist. Or else we're going to have a bad reference whenever the game mode tries to do something. So there should be a destroy override in here. We have destroyed right here. And this is basically whenever this actor receives a destroy event. So kind of like the opposite of begin play. So, and we should be able to do literally the same thing. When we receive destroyed, we're going to go ahead and unregister ourselves. So that should take care of our startup and our ending. Register and unregister ourselves with the game mode. So basically what is going to happen here now is we can test this. We have our register and our unregister. So let's set up a simple event in here. We'll just do a begin play event. And what we're going to do is delay for, I don't know, we'll go 3 seconds. And then at that point in time, what we're going to do is call our, we'll call another event that basically talks to all of our registered answers and does something. Our goal here is to basically, there's a time change event. So we'll call this custom event. We'll call this, we'll make it really verbose. Notify actors of time change. Now we're not going to set up any sort of multiple time changes and things like that. Again, we're making this very fixed. We're going to make sure it works. And then we're going to expand, generify, and just basically turn this from something that works in one specific case into something that should be pretty awesome, to be honest. And yes, to answer your question, Lex, the request was to make kind of like a day-night trigger system. Can we set up a system where items can register with the timekeeper, and then using event dispatchers, they get notified when the time changes, and then they do whatever they want. The goal here right now is to make something very specific, and then we're going to break it out into something very generic. And we're not even using event dispatchers yet. We're using like a manual dispatcher system. So notify actors. So all we're going to do is get, and we're going to for each through each of these. So this is going to grab every actor that's registered with us and do something. And in this case, since we know what we want to do, we're just going to basically, let's just turn on the light. We'll start off with our light off right now, and then we'll just turn on our light. So we know we need to handle light on. Handle light on. Now, obviously, we're going to have an issue. And again, we're going to fix these issues. The issue is this is just an actor. It's not actually the light. It's just a generic actor. It doesn't know it's a light. So, of course, we have to cast to our light. So cast to our BP light. And if it's a light, we're going to go ahead and turn the light on. I called handle light on. There we go. And again, this is specific, but will become generic. We're again just making sure stuff works at this point. And then this one is notify actors of time change. So we'll put this here. So now what should happen is whenever our lights spawn in, they should register themselves as a light, as an actor that wants to do something. And when our game mode starts up, it's going to wait 3 seconds and then notify any registered actors of a time change. And all that's going to do is loop through all those actors, cast it to a light, and turn the light on. So that should work. Let's grab our, that's a sky sphere, right? No, we need to grab our light source, and then we need to rotate it down like that. Is that it? Let's see. There we go. I wanted to give us a little bit darker, like that. So now we should have, after 3 seconds, the light turn on. Now the light should have turned on after 3 seconds, and obviously it didn't. So let's figure out what we broke, shall we? Let's see. Okay, so we broke something. Well, maybe we didn't break something. Maybe we just didn't handle this properly, because that's definitely possible. So let's see if it even gets here. We'll just reverse debug. We'll see if any of our lights are even being talked to. Okay, no, our light is not, this is not being called. So let's see if we can figure that out. Let's see, begin play. So we'll grab our game mode and we'll see if register is being called. So here's our register here. Because in theory this should have worked, but obviously I missed something. Okay, so that worked. So we are getting registered. So the register is working fine. So is this being called? Let's find out. This should happen after, we should see hello after 3 seconds if that gets called. Okay, so this part is being called. So our issue is our actors are failing right here. So let's see if we can figure that out. We'll go and run this. Wait for it to break point. And we'll go back into our code. I can get my mouse cursor back. Let's see. We are talking to an array that has nothing in it. So this is our problem. We never actually are doing anything to our array. For whatever reason, our array is empty. So we need to figure out why this array... Okay, so I know the answer to this one because, once again, I am completely inept at making arrays work properly the first time. I literally, not joking, literally do this every single time. So our array is of size 0. So when we add, it's not going to resize our array. So if we were to take our array and make it bigger, this should probably work. Cast a light, check out our array. Nope, our array's still 0. Son of a bitch. Okay, well, our array should have... Okay, so... What are we doing wrong here? Registered actors. Actor. Input actor. Actor reference. Okay, well, I'm going to call shenanigans on this one. Huh. Oh, ha! Okay, no. Yeah, that would be assuming one thing and not, yeah. Let's see, Lex. You only do blueprints, but do you think you can do the same with blueprint as with code? Because I know many things about blueprints, but almost nothing about C++. You can do 95% of the stuff in blueprints that you can do in code. The only reason you can't do everything is certain things are not exposed to code, exposed to blueprints, like the input manager. And hello, Harry. Nope, I assumed my mistake was the fact that I didn't have this resize, because I always make that mistake. But no, it's even simpler than that. When we are registering, we're not actually passing in anything. I should probably tell this thing that we are registering ourselves or unregistering ourselves. That might actually work properly. So let's run this again. We'll breakpoint. Now our array has an actual item, since we actually told it there was an item. And our light turns on. So there we go. I broke it. 3 seconds, our light should turn on. And there we go. Let's go back to our debug here. We can get rid of this, since I was smart enough to fix it this time. And now anything that is registered should work. So the nice thing is we could just literally put multiple lights around our scene. Every single one of them will talk to our array here, which is right here. Let me remove that. There we go. Every single one will talk to it, and every single one should work. Like that. So there's our basic system. We have stuff that can talk to the game mode. That stuff will then be talked back to by the game mode when we want it to. Now, we're not really going to set up our time of day stuff right now, because that's kind of generic. That's really do something when something happens. Our problem is going to happen now is, what if we have a light? And let's go ahead and duplicate this. And we'll call this one, what else might we want to do? A light. Let's do, we'll call this one cat, because it's the only thing I can literally think of. And we have let's say we have a cat. Now, the problem with the cat is our cat doesn't turn on. He doesn't really have a light. He'll either wake up or go to sleep. And in addition to that, our cat is not a light. It's a completely different blueprint. So if our cat tried to register with the game mode, it's going to fail. So let's just grab our cat here, for example, and let's hit play. All I did was rename it to cat and drag it into the scene. And you'll notice the cat doesn't light up. Well, our cat doesn't light up because inside of our game mode, we're casting to the light and telling it to handle light on, and it's going to fail right here because it's a cat. Now we could work around that. We could do, okay, let's grab this, and we'll do cast to cat, and hook it up to fail, and then tell the cat to handle the light on. Like this. Whoop, BP light, so that won't work, so we're going to have to, oh, no, can't do that, so let's see. Handle light on, there we go. So we can do it that way. And we'll go ahead and play this, and now our cat should turn on. And our cat turns on. So we're good there. Okay, but now we have a dog. Okay, crap. Then we're going to have to cast to our dog. And we're going to have to repeatedly fail and cast every time. Now there is a better way. And those are our blueprint interfaces. And I'd highly recommend using blueprint interfaces. And yes, this was definitely a flimsy pretext to talk about interfaces. I figured I would start off doing this the normal way, the fixed way, and then slowly roll it into a generic way. So Harry is right on the ball on that one. So interfaces are basically a way to talk to something generically, and they are super helpful because not only do they allow us to fix the problem that I can't find, our casting problem, we don't even need to cast anymore. So if we have an interface in here, we don't have to cast to our time of day game mode. And if we have an interface in here, we don't have to cast to our light. It's a generic way to talk to stuff generically. So let's make two interfaces. We're going to make a blueprint interface for a game mode. And then we're going to make a blueprint interface for... we'll call this... Oh, let's see. Usually you want to try to name this as what it is. Like the action type. So interactable, destroyable, explodable, something like that. Now this is going to be a way to talk to something that handles time of day. So we'll just call it time change. Well, this is a blueprint interface for time change, is what it is. Yep. So we'll just call it blueprint interface time change. I'm going to save everything because why not? So let's do our game mode one first. So let's open up our game mode, go to the settings, and add the interface, blueprint interface, time of day game mode. There we go. Now we have a generic interface attached to our game mode. And the reason I did this because it'll make the registering and unregistering a lot simpler. Lex, do you think Unreal will ever make something in blueprints to see what hardware the user has? Yes, I do. They already have it in C++. It just needs someone to expose it in native blueprints. Also, Rama has done that exact same thing. He's created his Rama plugin, and you can get hardware inside of it. That's the nice thing about the blueprints. They're just interface. The blueprints are technically just prettier C++. So you could technically do anything you want in C++, make it into a plugin, and expose it to blueprints. And now you have it in blueprints. I would expect Epic themselves to actually expose that at some point. They've done all the other game user settings so far, including, like Harry mentions, a benchmark, which technically tests the hardware. So I would expect it to show up at some point officially. Okay, back to this. Let's close our cat and close our light, and we have a game mode. We're going to make the game mode work for our registering. Now, we already have two things in here for registering. We're going to have to fix them in a second. So let's go into our game mode. Let's go into our interface for our game mode. There we go. And let's make a new function. We'll call this one register for time change. And we're going to call it specifically like this, register and unregister for time change. Because this is in our game mode, and because our game mode can technically do multiple things, we might want to have a time change event. We may want to have a We may want to have multiple events we want to track, so we're going to make it verbose. If we go into our light now and we check it out, so our register and unregister basically take in the actor. So let's copy that. So we'll go ahead and put a new input actor. You can, of course, name this whatever you want, but I name it like this so I can actually remember what I did. Save that one. So register should now take an input actor. Unregister takes in an input actor. Spelled properly. I don't know how I keep hitting the colon whenever I do that. Whenever I shift key, I hit the colon. Anyways, we have register and unregister. And if you look, their signatures should be the same. We go to our game mode, takes in an input actor. Our interface takes in an input actor. So we're good. Compile and save. Now you always want to compile after you do a change to an interface or else it's not going to show up. And you notice now it complains because there's more than one thing with the same name. Because we named our custom event the same as our interface event, which is good. We'll delete our custom events, recompile, and then add in our interface events. So this one's the register for time change. We'll just hook it back up just like we had this one. You'll notice now it has the little interface icon. And I think I don't remember what that icon is called, but a communication icon, we'll call it that. And it says it's now part of the Blueprint interface. And we'll do the unregister event. And we'll drag this sucker over here. We'll hook it back up just like we did the other one. And now these events should fire off properly. We do have an issue inside of our light because technically this isn't using the Blueprint interface function. If we were to go in here and type in, let's see, what was that? Register. Well, that's the unregister. So let's go down here. We'll do register. For time change, we actually find this version in here inside of our interface called message. And though these look the same, register for time change, target, input, this one has the icon. That's our little message icon. And it tells us it's using the interface. So we'll make sure we use the proper one by doing this. Now, this isn't even needed anymore. Because the Blueprint interface is generic, we don't even need to talk to the proper game mode. We can talk to any game mode now. I can delete our cast and hook right into our game mode like that. And all it's going to do is say, hey, Mr. Game Mode, do you know what this is? And the game mode's going to go yes or no, and it'll fail or it will succeed. But there's no penalty for failing. There's no need to cast. There's none of that stuff. It's going to talk to the game mode and try to do that. So clean this up a little bit here. We are going to unregister using our message. And the funny part about all of the stuff we're doing right here is we're going to technically get rid of it all once we're done. But this is also going to show multiple ways of doing the same thing. So that cleans that up a little bit. Now it's generic. Any game mode we can talk to now instead of the specific one. Because you might want to have a assault game mode and a shooting gallery game mode. You might have multiple game modes. And this way we don't have to worry about casting to all of them. Now if we run this, assuming I did it right, our lights should work. And there we go. So we have the same functionality as before, except now it's generic. Now you notice we still have a problem with this light, and that's fine. We're supposed to have a problem with it. If we go into our cat is registering with the time of day game mode and not using the message. And remember, before we had an issue in our game mode where we had to specifically call the cat. What we can do now is fix that. So let's go ahead and take our cat, and we're going to go ahead and fix up our cat here. This is also one good reason to have parent classes. We could make one parent class called, interact with time of change or something like that. Just generic actor that implemented these events. And then all of our children could make their own variations of it. So we're going to, what do we call that? This one's the unregister event. So we'll tell him to unregister. Oops. Like that. Compile and save, just because I like compiling and saving. If you have not gotten used to compiling and saving every time you do something, or even just saving. Eventually you will, once stuff stops working and you wonder why. So now we are generically registering as a cat. So we're good there. Now we still have our issue inside of, let's close our cat and our light and our game blueprint interface. We still have our issue of here where we are casting and we're talking to handle the light on. Now we can get rid of this and we could talk generically to those two items if they have an interface event just like our game mode that handles it. And we created one called Blueprint Interface Time Change. Now we're going to make this even more generic. Before we had inside of here, our little light and our cat, we had the event handle light on and handle light off. But our cat doesn't have a light. We want our cat to basically wake up. So we're going to make one generic event that is handled, well, one or two, I haven't figured out yet. We'll figure it out as we go along. But we're going to make this generic. We're simply going to have this item handle a time change. So we go to our interface. We'll rename our function handle time change. This isn't finished yet because I haven't figured out how I want to handle it yet. But for now, anything that implements this interface can handle a time change. Go back into our light. Tell our light, okay, let's go ahead and handle time changes by implementing the interface. Compile, or else it won't show up. And then we could do handle time change. Add the event, and there's our event for handling the time change. Now, for now, we're going to disconnect our turning the light on and plug this in here. Obviously, you might see an issue that we have no way of knowing if we're turning the light on or off. We'll deal with that in a second. But for now, we are generically handling a time change inside of our light. We go back to our cat, who's just going to simply glow because I don't have an actual cat. Same thing. Go to the settings. Tell this it handles the time change. Go ahead and delete this. Handle time change. And now it will do something when we handle the time change. You know what? We don't want our cat to glow. We want our cat to simply meow. So we'll print the string. We'll show how we can do different things all with the same interfaces. So it's going to go meow, meow. There we go. So when this thing gets notified of a time change, it's going to meow. And when this thing gets notified of a time change, the light will turn on. Go back to our game mode. Same thing. Our generic actors, we don't need to do handle light on. That was specific for the light. We just simply handle time change. And we tell whatever we are going to loop through, so all of our actors, generically to handle a time change. And the nice thing is this will talk to the light, it'll talk to the cat, it'll talk to the dog, it'll talk to whatever we want. We don't care what it is. It's going to say, hey, can you do this? And it'll do it or it won't do it. So, fingers crossed, if we did this right, we should have 4 lights turn on and it should say meow, meow. Yep, meow, meow. That light, that cat, meowed at us while these 4 lights turned on. So, there we go. Super generic using interfaces. Let's close down all of this stuff. And then let's figure out what our next issue is. So our next issue is our time change event is really generic. We don't technically even have anything set up for a time change. But because this is an interface event, and it can take inputs and outputs, or we can pass variables, we can pass the variable that we want. So we're going to make this really simple. I'm going to make this really simple, actually. You know what? Okay, so let's set up the time event inside of our game mode. I'm going to pretend that there are 24 hours in a day, and every hour is 5 seconds. So, I don't know what the math is on that. 24 times 5 seconds? That's way more math than I can think of right now. Let's go with like 2 seconds. Let's go with 2 seconds for an hour, because that's 48 seconds. I can do that math. Screw it. We'll go with 1 second. You know what? We'll just go with 1 second. So, okay, our day is going to be 24 seconds long. And for our purpose, it's going to work. Obviously, this will be adjusted however you want, but we're just going to say 1 second per hour in the day. I'm going to set up a really generic event here on our begin play, which I already have apparently, so we don't need to do that. I did something like a master clock somewhere, and it was basically this type thing. We kind of did that for the someone asked about changing the sky sphere time of day. We did something really generic with that. But how you get the information is up to you as a designer on how long you want this to work. We're just going to generically... The key is we need data to pass, so we're going to generically implement the data. So I'm just going to do a function that will call itself every appropriate amount of time, and then increment our time of day by that. That's all I'm going to do here. So let's do seconds per hour. We're going to make this into a float. And I'm doing this as a variable just so I can make it really easy to adjust. We'll go with 1. And we're going to call this right here. And then we're going to call our function, which I don't have created yet. So I'll have to create a custom event. We'll call this one increment time of day. And every time this is going to be called, we are going to increment our current time of day. Now, obviously, this is a very generic system. And we're going to show the different ways of using this here once we move to the full event dispatcher system. So this is our current time of day. We'll just grab this. We'll add... I hate how the friggin' array it shows up every time. And we're just simply going to add one. We're going to add our second. You know, that would be smarter because then it's a variable. And then we'll set our current time of day. Set our current time of day. Like that. And this is just something really generic. Basically, every time it gets called, it's going to add 1 to our current time of day. So midnight, 1 o'clock, 2 o'clock, 3 o'clock, etc. We'll make sure this loops around properly. So if this is greater... let's put this here. We're going to put this here. I want to do the check here before I even set it. So if this is greater than, and we'll do something, number of hours in day. We'll set this to a compile, and we'll set this to 24. So if our current time, once we're done here, is greater than our number of hours in the day, so we're basically going to loop around. We've gone ahead and looped around at this point in time. This is actually kind of curious on this one, because technically we need to treat 0 and 24 as the same. I'll worry about that in a second. Again, you should be using a real-time system, not this generic thing. Yeah, okay. And I'm going to use the select for this because select nodes are freaking awesome. I don't want to use an if node, so I'm going to do a select node here. Okay. So we're going to make this, again, really generic. Not really generic, but really customizable. So if we have too much time, then we're going to return back the time adjusted. If we don't have too much time, then we're going to return back this value right here. That's what we're going to do. So if we have too much time, then our adjusted value is going to be what? It's going to be this number, and then minus the number of hours in the day. Yep. Okay. I know this looks kind of funky, but I don't like using if nodes if I have the choice. Okay, so I'm looking at what James is bringing up here. Yeah, see, this is in the... this says it's in the game state. That may have been something that they implemented themselves. Because you have to keep in mind that because it's in their shooter game state. See, I'm not seeing anything for get daytime. I mean, I have get time, and I have the ability to get the current time from the engine. So, oh, I could technically do that. That's probably just, let's see. See, because what you could do is you could get now, and then you would split now up, and then your daytime string would be like this one. Well, let's see. Daytime string. I don't know how they have, let's see. Returns the day and time string as seen in the inventory. Yeah, see, so that's a custom node they created. They did something like, you know, append, and they did something like that space, you know, you could have had something like that, and then let's see, day and time. See, and then you would have had to grab like the hour and then append to something like that, and then the minute to something like that, and then maybe colon, and then the second. And then this is the output result right here. This is a lot of things stacked on top of each other. Yeah, you do something like this. My guess, because you pulled that from the Arc Wiki, is that is a custom node that they created basically roughly like this. Grab the current time, grab the information, append them all into one master string, output the string. And then they have a custom node. And technically day wouldn't even be the right one here because they're using, that's all custom information, yeah. So yeah, you have to implement your own time system somehow. And we're just generically creating one here. I don't even know if this is freaking gonna work properly, but we're gonna find out. That's what my goal is here. Okay, so increment the time of day. This should increment the time of the day, and it should loop it around. We need to call ourselves again. So let's put ourselves here. Increment time of day, like that. Let's grab ourselves and paste ourselves. And this way, we basically have ourselves looping without actually calling the loop function. We're just going to keep calling ourselves every time we need to. I'm going to debug this for a second and tell it to output the time of current time of day. Seriously, you know, you can drag from here, but you can't drag onto it. Let's see if this works. 2, 3, there we go. So that's going to basically, it should over 24 seconds loop over our time of day, basically. I'm curious what happens when I hit the top, though. I think it's going to hit... actually... Oh, if I do greater than or equal to, I bet you I can get it to go back to 0. If I change this node to a greater than or equal to, it should hit 24 and then subtract itself and go back to 1. So that'll take care of that. And this is just a select node. Instead of doing an if, you can use a select. And all this is saying is add the time in this incrementation. So go from like 0 to 1 and add it. So our output's 1. And then it checks and sees, is 1 greater than the number of hours in the day, greater than or equal to, which is 24. Which it's not, so go ahead and just change our current time of the day to 1. If it is, then go ahead and do a little bit of subtraction. Subtract the total number from the current number and put that into the current time of the day. Select nodes are basically a way to pass data without using an if by technically using an if. It's just one less node, and they look kind of funky, but they work great. Okay, so we have our time of day, and we have... Here, let me move this down here just to give us some room. Basically, now we have our time of day functioning, so let's move this up here. These are our 2 events for registering. Okay, so now we basically have to do this. Our event here that's going to notify the actors the time change. I'm not worried about calling it yet. Let's update this. So this is our handle time change. The nice thing is we now have an actual time. So, oops, not input, output. What we're going to do, no, not, okay. For Pete's, oh, I broke it. I hate when this happens. Oh, man. So that was a break on accident. Okay, so if you ever friggin' accidentally add a stupid return node to one of these functions and then don't need it, you kind of screw yourself up. It's just really friggin' annoying. I hate that. Anyways, I meant to do an input here, and this is going to be the current time. It causes issues inside of here from time to time. And you can't technically get rid of it in here, which is really annoying because we're not using it anymore. But that should be that, and then current time. Now we're going to pass, whenever we call the time change event, the current time. So now our items can react appropriately. Now this is probably not the best performance way, which is why we're going to, when we switch over to the event dispatchers, we're going to change some things up. But this way is the easiest way to illustrate, well, the problem we're going to have. Anytime we call notify actors of time change, we're basically going to tell them all what the current time is, and then we're going to let them handle things appropriately. Now we should probably call the notify actor whenever the time changes. So we get rid of this. We'll grab our notify actors time change node, and we'll call that. So every time the time changes, we're going to notify everybody, hey, the time changed. So now if we go into our events that implement this, so for example, our light, now our light can actually check and see what time it is and do things appropriately. So our light, you know, we can make turn on time, and our light can have turn off time. Change this into a float and a float. Save those. We'll go ahead and expose these because I want to do something fun. So the turn on time is going to be, let's see, I'm running this in military time. Let's call this 18. We'll turn on the time at 18. And then we'll turn off the time at 6. That's what we'll do. Now we can get rid of this one right here. We'll do just a simple if check. We'll do a simple if check. Oh, I can't do an if check off a float because it needs a boolean. That was really silly. And we'll do a true and a false like this. Unhook this for now, and we'll do just a little if check, and we'll do an equal. We'll do a nearly equal. You should probably do integers for this, not wow, brain, come on, you can do this. You should probably do integers for something like this, or a continual integer value. For example, 1, 2, 3, 4, 5, 6, and round out after 24,000 or something like that. Because when you're using floats, you might have the floating point precision issue. So for something that's definite, I would recommend using integers. But I don't know. I literally don't know why I'm saying that when I could just do that right now. So let's change this over to an integer because I can. And I don't know why I'm telling you to do this and then not doing it myself. So we're going to change these things to work on integers because integers don't have floating point issues. There we go. So our current time of day is now an integer. And we can easily just simply fix this stuff here. Set a current time of day. And all this is going to do is truncate it. And then seconds per hour. See, that should be a freaking... Yeah, I wanted to leave that open, but you know what? That's just stupid to have half-second stuff. I'm changing everything over to integer. Screw it. It makes it easy. Because honestly, we should not be... Oops, context sensitive. Don't deal with floats. If you have the choice, don't deal with floats. Floats can lead to issues that you don't want to deal with. Obviously, you need floats when you need precision, but in this case, we don't need precision. Things are equal numbers. Minus. There we go. Oh, now I gotta change our select node. Wait, I should be able to just change the pin type, right? Wait, I gotta unhook that one, and then I can change it, right? Yeah, there we go. I didn't want to have to redo that whole stupid thing. Wait, this one's true, and this one's false. Oh man, I forgot which one's hooked up to which. That's right? I think that's right, right? If the current time of day is less than... Oh, less than... Yeah, that should be good. Okay, so that outputs it out. There we go. Now we should have integers we can pass through. And then This one's not an issue. We'll just convert this over to the float. Okay, so we'll go with that. Let's see. Atlas, how many years have you been game programming? Programming in general for near 30 years at this point. And programming games in general, I've done games probably for the last 10 years or so. Well, official games for like 10 years. I did stuff before that, but it was all, personal fun stuff type things. Let's see. James, sorry to be a pain in the ass. You are not a pain in the ass. I appreciate every question because hopefully everyone can learn something, or I can. The page has the source code for the daytime string. How would I implement that code in Unreal? You could either convert that over to blueprints, kind of like you saw me do. So basically turn the C++ into blueprints by looking at each call and then finding the appropriate node, and then make yourself a function library or macro library. If not, you could probably just grab the entire chunk of code and create your own class inside of Unreal Engine. Just do a new, whoops, I need to be in here, a new C++ class and do that. But you're going to need to have Visual Studio installed to compile it. And depending on how you want to integrate it, you may even need the source code, the actual Unreal Engine source. Your best bet would probably be to figure out how to implement that function in blueprints. You could just add it in as like a function library. And hello, Sterling. Good morning or day. Wait, you're in California, I think. So good day. Okay. So I think we got everything converted over to ints. It looks like it. Okay, cool. So now we should have integers we can pass. So now we go back to our light, and then we will do a equal to, because now we can actually do an equal to. We'll do this one. Can I do a select? Let's see. I can do a select int, but can I do a select int? It's not what I meant. Switch. I meant to switch. Okay, mouse, come on. Okay, mouse. There we go. I think my mouse is going out. Switch on int, not ion int. But I don't think we can have a switch on int with only 2 pins. That's kind of like what I'm looking at right now. Yeah, see? I was hoping we could, for example, have a switch on int that only had 2 numbers on it. But we can't. So we'll do this. We'll unhook this for now. If it's equal to our... Oops. We can turn these back into integers. This is 18 for the turn on. I have a cat trying to get on my keyboard right now. This is not going well. Get on the desk, not on the keyboard. Harry, yes, Unreal does have a date-time structure. But I think his biggest issue is the if he's working on Arc has its own time system that's probably ran on internal timetable. I think that's the biggest issue. Okay, so we have a turn on time at 18 and turn off time at 6. So if we're equal to the turn on time, then we want to turn on our lights. If not, we will do another check here. And we'll do an equal to. We'll see if we're equal to our turn off time. Let's see, we'll do another if. And we will reverse it. So there we go. So if we pass in the turn on time, we should turn our light on. If we pass in the turn off time, we should turn off our light. And that should work. Our cat really doesn't matter. He's just simply going to meow probably every single frame. So let's see what happens. Okay. So obviously we're not registering properly. Someone broke something. I'm not going to say who. But I have a feeling our... oh. Nope, it's not that. I don't think we ever call our... Where's our begin play event? Up here, right? Yep, we never actually call our set timer function because we changed this over to an integer. So that would probably help. There we go. Okay, that was the first try. Increment time of day. Let's see. So let's make sure that's functioning. We'll find where we hit that. We'll put that here. Let it play. That never gets called. So obviously someone did something that doesn't work properly. So let's go back up here. Did we spell it properly? That's probably the first thing to check. Our game mode is running, right? That's probably our next check. Oh, that's easy enough. We just F9. Okay, so we know that's running. I have a feeling I might have misspelled something. So let's see. Increment time of day. Paste. No, I called that the same. Oh, I probably, didn't, See, you know, it helps if you actually fill out variables in here. I forgot when I changed these from a float back to an integer. Technically, nothing was working. There we go. So now we should meow every second. And you're only seeing 2 because it's set to 2. After 6, the light should shut off, which it is already off, so not an issue. And then once we get to 18 seconds, the lights should all turn on. And there we go. And then after, 8 to 16, another 10 hours, 10 seconds, the lights should go ahead and shut themselves off. Assuming I hooked up the shut off code properly. Which is a definite possibility I didn't. Okay, so obviously that didn't work. We are still meowing, we're just not shutting off properly. Oh my gosh, seriously? Ah! Oh, hooking up nodes. Apparently hooking up nodes is going to be my nemesis today. So we'll let this meow for a little bit while I look through chat. Alex, I did see your question. Give me a second to go back to them. Yeah, and Harry, of course, noticed exactly what I did wrong because my brain is non-functional. There's a really bad flu going around up here. I think everyone has it. But if you notice, we have our lights turning on and turning off at the appropriate times. Let's see. Yeah, there we go. I was like, why the hell are they not shutting off? So we have an event that fires off now. So our cat, of course, should probably be fixed because our cat was more for demonstration purposes than anything. We can easily grab our code here, which I'm going to because it's super easy to grab. And we'll just simply do something like this. The nice thing is I'll delete these variables, hook up these ones properly this time. And we'll have the cat wake up at... cats are annoying. They'll wake up at 4 o'clock, and then the cat will go to bed at like midnight because cats are friggin' annoying all day long. And then we'll just print out. Cat wants to eat. Cat wants to eat now. And then we'll have print string. Cat went to bed. Cat went to bed. Finally. Okay. So it should be fine. No more spam. But at 4 o'clock, the cat should wake up. And then 2 hours later, we should get our lights turning on. Or technically turning off. Because, well, they were off. They were supposed to be on, but we didn't do that. Cat goes to bed. Lights should turn on. Did I? Oh, because 12 obviously is not 24. Because my brain isn't smart. So let's send him to bed at 23. Anyways, you guys get the basics of that. It's pretty simple in there. The items can handle a time change, and then they could do something appropriately. So you have a generic event, and then you have specific actions. In this case, the cat does something at certain times, and our light does stuff at certain times. And of course, if you have a dog, it can do things at certain times. People can leave work at a certain time, like if you're thinking of The Sims and things like that. You have one generic thing that handles events, and then it passes that information off when it's appropriate. Now, this is basically an event dispatcher system. We're basically registering with something, and then asking that something to do something when it's appropriate. I know it's a lot of somethings, but it is generic on purpose. So in this case, we're registering for a time change, and then when it's appropriate, we are telling everything, which is this part right here, that a time change occurred. Now we have the ability to do this using event dispatchers, and that's what we're going to switch it over to here in a second. Alex did ask a question though. Is there a reason why mouse right left button clicking doesn't have executable events? How come you have to use them when you override functions? So I think I asked, tried to answer this one at one point, but I don't know if I got the information from you. What do you mean by they don't have executable events? You have input events that handle the mouse clicks, and you have direct actions in here, like for example, mouse left button. If oh, for Pete's sake, cat, like this one, a mouse event right here called the left mouse button, and then you have the right one as well for the mouse button here. So you do have actual keys. So like for example, it would be the same thing like if I did the E key here. You have to do E like that. So you have different ones in here. So these are your actual generic input events. Yeah, those are your generic input events. But the traditional way of doing them is inside your input manager and assigning them to an actual action or axis mapping event. Like for example, in here I have the left mouse button. I thought I had it assigned to something. I thought it was, oh, it's interact, right? Right here, action. So this is the traditional way of doing it. Action map it, name it, and then assign it right here. But either one of them should work. Your biggest issue with the mouse, where to go? For whatever reason, I don't really know why. If you do the E key, for example, it'll show up with where'd my E key go? Dang it! E key. There we go. Seriously, are you going to? Oh, I'm in the game mode, so that's why it's not showing up. But you may have to uncheck the context sensitivity if it's not showing up, because that's where all of your key inputs are going to end up showing up. So that is something to note. How come you can't use executables in widgets? What do you mean by executables? Do you mean the input actions in widgets? The do you mean like those ones in here, like the E key? Which of course isn't showing up because it doesn't like me. But yeah, if you mean why you can't have it work in here, it's because it's designed not to work like that. Technically, no input goes into the widget itself. You have the listen for actions. Yeah. In order to make those work, you have to do something that was added in what you probably don't have. You have to do the listen for input action nodes. This one allows you to listen, for example, input action, which if we go back to my project settings, input action mappings, I have my input action mapping right here. You have to listen for that inside the widget and then do something. This is how you can listen for keyboard input inside of a widget. And that was added in 4. something, 12 or 13, I want, maybe even 11, but somewhere around 11 or after, I believe, is when this was added. And this is for input actions going through. But that's just the way they're designed. Widgets technically don't exist in the world, so they kind of can't listen for input. That's the biggest reason why. You have that as the workaround. I mean, technically, if you're in the user interface, you could override the key down, and you could listen for the key down, see if the key is equal to. Oh, for Pete's sake! Seriously, you're gonna do this to me right now, you stupid thing. Here we go. You could do something like this, and you could listen for a key on the key down, like that. This is something you could do as well. So like if you wanted the left mouse button, well, technically that's not going to work. Well, I guess technically it would, but that's more on the mouse down. You could do something like this, and that anytime the key is down, it'll check and see if it's the K key, and then you can do something appropriately. That's just the other way of doing that, but it keeps it specific. It has to be this specific key. Doing it the listening version, it doesn't have to be that one. It could be the one that you've defined in the input here. So those are two workarounds. Let's get rid of that event. There we go. Okay, so we are on event dispatchers now. So we have a whole bunch of code all over our place. And we want to try to do basically what we did, but using the built-in system. And that built-in system is event dispatchers. Event dispatchers are these funny little things down here under your variables. And if, for example, I was to grab like this one and bring it in, it's going to give me a list of stuff. And this list of stuff is basically registering and unregistering, binding, events, calling, things like that. So you can see binding, unbinding, and stuff like that. So we're going to switch our stuff over to, let me get rid of this stupid search. There we go. To the event dispatcher system. We know that we have our items. So in this case, I lost my folder, so that didn't help. We have our cat and our light. And then we know how we have our game mode, which is what's going to do the stuff. So somewhere in our game mode, we need an event we can talk to. And then, well, actually, that's basically the biggest part. You need an event that you can talk to. And by game mode, I meant game mode, not the actual blueprint interface. So let's find our game mode. And right now we have our register and unregister events. Let's move these to the side. Let's make a new event dispatcher. And we're going to call this one time change ED. Time change event dispatcher. And we're going to go ahead and go in here. And technically, would we do the call? We don't need the. We're not going to do anything in here. We're just going to create the event dispatcher. We'll set it up here in a second. The key is now all of this code right here, we basically did by doing this right here. Literally. Now that we have an event dispatcher, we can register and unregister it from our items. So if we go into our, where to go? Our light, for example, we can now talk to our game mode and we can register. Now we do have a small problem. Unfortunately, if we go in here and you do time, where's it at? What do we call that thing? Time change ED. You're going to notice it doesn't show up. I don't believe you can generically set up event dispatchers. That's the problem we're going to run into here. Using interfaces, we can generically talk back and forth. But unfortunately with event dispatchers, because they're inside of here, it needs to know that it exists, basically. So I want to say, let's see, because this is the event. Bear with me on this one. I want to make sure I'm not crazy here. I'm just going to drag them all out. I don't use event dispatchers a ton. Yeah, this is bind. Yeah, see, so none of these are going to allow us to yeah, so none of these are allow us to do what I want to do. I was hoping we could, but we can't. So we're going to need to go ahead and redo these, kind of like back to what we had. Keep in mind, there's multiple ways of doing everything. So you may not even want to use event dispatchers. You may want to use that system we created so we can use blueprint interfaces. The nice thing is once this is all done, you'll have a bunch of different ways of doing the same thing. Figure out what works for you. In this case, let's just unhook these for now and drag them up so that way I can basically not have to mess with this existing code. And we'll get our game mode. And we're going to go and cast our game mode back to our time of day. So kind of like what we had before. And this time we should now be able to bind to event time change ED. So what this is going to do is whenever time change is called, this event is going to fire off. That's what these funky red event nodes are for. We're not going to hook that up yet. We're going to do the opposite of what we just did now. If I didn't do this, then I would friggin' forget, and then it would never work. Getter game mode, cast it the time of the day, and unbind from event to time change ed, like that. So basically this calls a bind and this calls it unbind. Now down here we had this event handle time change. This is the event that's going to get called when our event dispatcher does something. Using event dispatchers, you're basically binding specific things. You're linking up or chaining together. It's called binding and unbinding, basically. Things together. So you're basically saying, when this happens, do this. When this happens, do this. So it gives you more, not necessarily more flexibility, but it allows you more control over what's happening because you tell it literally what to happen. So down here we have this right here. These red things need to be connected. This is kind of where one of those issues comes in. Now, there are ways around this. You could technically cheat. And let me show you how to do that right now. So we'll make a custom event. And we'll call this one, call the time of day change, right? Is that what we called it? What did we call it? Event handle time change. So let's just steal that. Oh, see, that's a blueprint interface. We'll have to fix that anyways. But this right here, call the time of day change, and this right here, this is basically our fake way of keeping things clean. We have a custom event that simply does something, and all this is going to do is call this down here. So that way it basically, instead of having a line going from here down to here, or having this bit of code up here, we're basically passing off control is all we're doing. Now, since we're no longer using interfaces, we're using the event dispatcher, we're going to have to get rid of this. So let's just unhook this for now and move it out of the way. Make a new custom event, and we'll do handle time of day change. And we will hook this back up like that. Now, obviously, we don't have a variable set up properly, so we're going to need to go back into here. Here's our time of day change. We need an input. The cool thing is you can copy signatures from other things that exist. It would let me scroll. It won't let me scroll. That's really annoying. But if you had something in here, for example, that was already set up to do what you wanted, the signature is, whoops, let me close this. The signature is this part, the part that defines the inputs and the outputs. So you can technically copy things easier. We don't really care about that. We just have a new input, and this will be the, what do we call that one? Current time. We'll do that, and that's an integer. And there we go. So current time. So it's going to pass the current time. We'll go ahead and set up handle time of day change. And you can see we now have current time in here. And then all we're going to do is grab, whoop, go back to here. Yes, this is the fun part about coding, is all the refactoring as you figure out stuff. Everything was going fine and dandy until we decided to change everything. But this is just showing alternate ways of doing it. And the nice thing is, hopefully once you understand the different ways of doing things, when you're designing your game, when you're doing your design document, or you're planning out your design, you'll take a couple minutes and you'll think about how you want things to work. And you'll know that you have a bunch of options. And you'll evaluate your options, and then you'll make a choice that will work for you without having to spend a couple hours of experiment. You'll know, okay, well, in this case, I need blah, blah, blah to happen. I have these options. I think I'm going to use this because it'll give me the best result. Okay, and then we'll find our event script, and this one's called handle the time of change, like that. See? This is just, right here, this is just a cheap and easy way of passing off things from one thing to another. Once this gets called off, this gets called, it passes the information to there. I can double click, I forgot. And then this will call this. So it's our same code as before. The only difference is we're not using our interfaces, we're using the event dispatcher to call this off. So in theory, this works. We just need to somehow call this event. Inside of our time of day change, we already had something implemented down here, which is notify actors of time change. And remember that simply looped through everything and told it to handle the time change. Since we have an event, we don't need to do that anymore. We just simply call our event like this and pass in the appropriate information, which is the current time of day. We'll just leave this here because that's our old one. And you know what? I can comment this as BPI method. There we go. So if we did everything properly, which usually takes me 3 times to fix stuff, but if we did things properly, our new system should work. We should now be using event dispatchers to work. Are we? I don't know. Let's find out. Let's see what happens. I don't think I set up the cat, so the only thing that should be working is the lights. And this is also one good reason to have like a parent, so you can do all this code at once. Now obviously something didn't work. Well, obviously, because it didn't work. That was just a really silly way of saying that. So let's see if our events are firing off. So let's go back to our game mode. Where's our begin play? This should simply still call our increment, our timer function. Increment time of day should go off after a minute, and it should call everything that is registered in terms of time change. So let's see if that event fires off. And it is. So anything that is registered in here should do something. And obviously nothing is happening, so we need to figure out why. So let's go back into here. On begin play, we should... Oh my god, seriously? Okay, so... if you are binding events, it would probably be smart to hook them up properly. I was on begin play, unbinding. And then on destroy, binding. That probably isn't helping get my goal done. Let's try this again. So now after roughly 6 seconds, we should see if I did it right. Yep, there we go. It only took 2 tries that time. Did you see that? Didn't take 3. But now we should have the same results as before with our blueprint interface, except now we're using dispatchers. So our lights come on at nighttime, they'll cycle for a bit, and then when the daytime comes in, they'll shut off. And of course our cat is doing nothing because our cat has not been changed. Now you may notice something that's advantageous for blueprint interfaces and stuff like that. Our cat exists in our world, and our cat is technically registering itself by calling the registered and unregistered events on the game mode. And our game mode is happily taking that information and doing stuff with it. Now if I was to delete these like that and get rid of those message interfaces, we've now converted over to the event dispatcher. We no longer want to use blueprint interfaces, and oops, we accidentally forgot to fix some of our stuff. Well, when we play this and everything's running and we close this, we get no errors. That's the nice thing about blueprint interfaces. Remember, when we use a blueprint interface, it just asks nicely. It says, hey, game mode, can you do this? The game mode's going to go, no, I have no clue what you're talking about. And then that's all that's going to happen. No errors, no faults, no crashes. It just simply can't do it. So it doesn't do it and it fails silently, which is nice. So that is an advantage of using the blueprint interfaces. You'll also notice we accidentally unbound an event even though we didn't bind it. That's fine as well. It's going to simply remove it if it's available. If not, nothing happens. It's one of those simple things where, hey, can you do this? Well, okay. Nothing happened, but I did it. Now that's pretty much it in terms of that. We've gone through the exact system of talking to our lights and doing something. We converted that over to a system where it was using blueprint interfaces to generically talk with stuff. And then we moved it over to the built-in event dispatcher system. And it's now handling it using the event dispatcher system. The nice thing about event dispatchers is, again, the registering and unregistering are built in, so we don't have to do that. You can also, if I remember correctly, if I can figure out, let's see, where is my interface? I want to say, whoops. Let's see. I wanted to say we had the ability to see what things are registered to it, but I don't know. Maybe I am wrong on this one. Yeah, I might be wrong on. I know in C++ and the other code languages, you can find out what is bound to events, which things are listening, basically. But I don't think it's enabled inside of blueprints that I can tell. I was just curious. That was all. Okay, so let me go ahead and if there's any questions on this one, let me know. I will slowly go over each of the blueprints so that way people who are watching it in the future can keep track of what we've done. One thing that's nice about the blueprint, this system here, the event dispatchers, is there's no real penalty for having extra event dispatchers. So as a way to improve this, you might not want to have you might want to, okay, so maybe you want something that will increment every hour. So example, time of day. Maybe you need something that runs specifically on certain hours. But maybe you need something that doesn't. Maybe you need something that is specific. Sunrise and sunset, for example. You could easily have an event dispatcher called, sunset event dispatcher. And then you have another one called sunrise event dispatcher. And you could have specific ones inside of here. And then, for example, when your time of day goes on, and you notice how it calls time of change, you could then have another check in here for this, and you could have, let's see, so let's define two variables in here, because we would need to know this. So sunset time and sunrise time, spell it properly. Compile those out. So our sunset time is going to be 18, and our sunrise is going to be 6. And then you could basically do the same things in here. So if our current time of day is equal to the sunrise, sunrise variable, that would help. Then we're going to go ahead and call the sunrise event dispatcher. Oops. Yeah. Now you might want to use something like a sequence or something like this, but this is just our basic setup right here. And if not, we could do something, for example, sunset. We're going to call this one if our time of day is equal to the sunset time. Remember if. Obviously, this is not the most efficient branching system. Something more like either a select for. So, for example, you have the ability to switch on int, and you could, whoops, that would be the zoom button. Okay. Yep, I definitely think my mouse is having an issue. There we go. You could add in a pin for every single hour in your day, and then you could simply feed in the time and then have it call the appropriate event dispatcher at the appropriate times. And then all you have to do now in our light, for example, so in here we were registering for the time change event and the call the time change event, and then handle time change where we're passing in the time. We don't have to do that. I'm going to keep these here for reference because I'm not going to do the destroyed one this time. I'm just going to do the begin play because we're not destroying our light. So that would be something you'd put in. But we could basically grab this like this. and then we're going to bind to sunrise, and then we're also going to bind to sunset, like this. And now we have two events we are bound to, sunrise and sunset, like that. And of course, we need our little thingies, so we'll go down here, and you notice how we had these checks inside of here? Well, what if sunrise and sunset changed? Maybe you had a seasonal system, and your sunrise and your sunset changes. Well, then you'd have to go in and either define turn on and off globally somewhere else, and then pull it in from somewhere else, or you could just simply have this item, which is a light, which has certain things it should have react to, simply react to them. So in this case, we could set up, so this is our old one right here. We'll just move it down for a little bit, and we'll call a custom event handle sunrise, and custom event handle sunset. Let's see, sunset turns the light on, and sunrise turns the light off. So actually it should technically be like that. So now we have these two generic events calling our sunrise and sunset, and then we just simply have to bind to those like we did before. So, I mean, technically, we could drag this crap. You know what? I mean, like, for example, remember I said we could generically do our pass-through, and we did our pass-through over here. This is the way without the pass-through, just in case you were wondering. Oops, I just organizing stuff is all. There we go. So without pass-through, we'd have something like this. Sunset hooks into there, sunrise hooks into there. So, I mean, you can see how this could get a little ugly doing it like this, because your bind events have to be on top of your calling events. So that's why we did it this way up here, so it looked a little bit cleaner. But by doing it like this, in theory, if we hooked it up right, again, in theory, now we should have it rise and sunset based on when the game mode tells it to happen. So let's hit play and try that again. So let's see, after 6 seconds, we should see a flash of light as our lights turn themselves off. There we go. And that does that because I simply don't have my lights turned on at the beginning. You know, small thing I don't really care about, to be honest. But our event dispatchers are now firing off properly. Every second, we're calling off, hey, something happened every second to whoever's listening. In this case, nobody's listening. And then also at the appropriate times, 18 and 6, we are calling off sunrise, well, sunrise and sunset, basically. So we've defined sunrise and sunset. Just because that is actually starting to annoy me at this point in time. I know I said I didn't care, but I lied. We're going to make the light turn on by default. There we go. So our light's turned on by default now. So now the nice thing is, the game is defined, you know, sunrise and sunset as 6 and 18. And sunrise will pop up in a second, our lights will dim, and then it'll continue. But we can easily now define sunrise and sunset inside of one place, and anything that's listening to the sunrise and sunset events will act appropriately. Because the event dispatcher basically says, hey, yo, something happened. I'm going to notify everybody who wants to know about this that something happened. And then everything simply that wants to know about it goes, yo, I want to know when this thing happens. So you can have all of your events defined in one place. Anything appropriate can listen to the events. And you can multi-bind. As you saw in there, this one light is bound to sunrise and sunset. It could also be bound to, I don't know, a global thing. You could have an event, for example, called power outage. And anything that runs on power can bind to that event. So when there's a power outage, it tells everybody, hey, there's a power outage, and then the item acts appropriately. So rather than your light checking every frame or every so often if it's got power, it can simply be notified if the power is on or off and then do something appropriately. So you think of it as this is a central dispatcher for events, and then it dispatches that information. Now there is more to events than that. You do have the ability, as you can see in here, not only binding, unbinding, and calling. You have events and you can assign things. Those are kind of like shortcuts, like you can see in here, how bind event. So you know how we were calling the bind event in here? If we assign Oh, I need to actually call this right here. Assign. Right here, assign. You'll notice how it basically creates for us a bind event and a custom event to bind to at the same time. It's a shortcut, basically. You saw how we did this by hand. This just simply does it in one stroke. It's a shortcut. I think that's pretty much it. Where'd my studio go? We've been recording for 1 hour and 36 minutes. Lex, to answer that question, I don't make money with this. I make sure I purposely have ads and monetization disabled so that way people don't have to wait through stupid stuff to get information. I do this on my free time, but I am doing contracting work and other things for Epic. So I do make money, but not directly from this stuff. This is just simply doing things in addition. I don't have a need for money, so I'm not really worried about it right now. I do it because I enjoy it and because it's a hell of a lot of fun to show people stuff and hopefully help them when they get stuck. Because I know when you get stuck, it is a definite demotivational thing, and getting past getting stuck and seeing your project working and going, I just spent 3 hours typing up code or wiring blueprints, and now all of a sudden everything works. It's an awesome feeling, and I love that personally. And then of course I learn new stuff like now, or I get to do different stuff like this. So that's why I do it. But I think that's going to wrap this up. Let me close down my blueprints. This is a suggestion Sterling gave me, and just go over my blueprints so that way people can see how they work. So we're going to go through the ones inside of our items first, and go from there. So using blueprint interfaces, we basically register or unregister, and by getting the game mode. Using event dispatchers, we basically have to talk to the game mode, bind our event to it, and then do something with that event. In this case, I am generically passing from one event to another just to keep things clean. So, hey, game mode, you're a time of day game mode. Let's bind to when the time changes, and then let's go ahead and handle the time of day change. The third one, which we did down here, was the same thing, except we're actually binding directly to our event. So same thing, get it, cast it, bind to sunrise, bind to sunset, handle sunrise, handle sunset, and all that does is basically we're lerping a color intensity. So something super simple. This can obviously be whatever you want. And we have wires everywhere. Because what's funny about this is technically, right now, I am listening for sunrise and sunset. If I was to hook up the bind to the time of day change, I could have it do that as well. So I could technically listen for sunrise, listen for sunset, and listen for time of day change, and have everything hooked up appropriately. This code in here, for checking to see if we're at the appropriate time of sunset and sunrise, we basically moved over to the game mode because now the game mode's in charge of it. Now, our cat is the same. I'm not worried about our cat. This was just simply an alternate way of showing how to talk to different items. If we were to hook up our cat the same way we did as our light right now, using the event dispatcher, it would work the same way. It's simply going to talk back and forth. The event dispatcher is a generic way. It's kind of like blueprint interfaces, but it knows who it's talking to, so it passes the information back. Lex, a jetpack blueprint for 2D side-scroller. I can try looking into that. Unfortunately, I don't use 2D at all, so I don't have any information about the paper 2D system. I'll add it to my list, and I'll look into it, but I can guarantee you it definitely wouldn't be anytime soon. It shouldn't be much different than a 3D blueprint in terms of you give an impulse and that impulse fires it up. You're going to want to look at the impulse system for physics. The 2D movement system, as far as I've seen, still uses the existing character controller. It's just using a flip book for the animation and locking it to one of the planes, so you're not like going in and out of the screen. So if you look at just a simple jetpack instruction or how to use impulses, that's how you basically use do a jetpack. Okay, so our blueprint interfaces are really simple. When we used it to handle the time change, it's simply handle time change, and it passes in the current time. The time of day game mode, this is one we're using for registering, and it's just registering whoever we want. It's just an actor reference, and unregistering whoever we want. Another actor reference. So super simple. Our game mode is where we handle all of our code and try to keep it as separate as possible. And these were really simple. This used to be, let me put these back in. Register, time change, there we go. Bloop. And then unregister. This is before I took out the blueprint interface to show you that it will fail without failing. So these are just our interface events for registering and unregistering. When we didn't use the event dispatchers, we just simply grab our actor that was passed in and add it to an array. And then when we unregister, we simply grab that actor and remove it from the array. So super simple. The begin play, we can ignore that for now. Our notify actor time of change. This is our blueprint interface version. We basically grab all of our actors, loop through them, and then tell them, hey, here's the current time of day. And remember, we're using the interfaces, so it's really super generic and it's not really an issue. Now, when we're using the event dispatchers, we are basically using this version down here. And this one is simply calling the event by grabbing the event and calling it, and then whoever's registered with this event will get the information that we tell it to. And yes, Lex, you just add force to the character on the z-axis. That's pretty much it. Impulses are generally what they would use. That's an impulse is a burst of physics energy, basically. So think of it as like when you turn it on, you get a little burst, and then so all you'll do is like push your jump button, add impulse every tick till you're going how you want or whatever, and then when you let go of the button, stop adding impulse, and then forces should naturally drag your guy back down. Okay, so yeah, all we're doing here is simply calling the time change, or calling sunrise, or calling sunset when appropriately. That's all we're doing here. And of course, you can ignore overlapping stuff because I don't care about that. This right here, this is just our super simple, really generic, silly time of day system. We're literally just adding one every second to our time of day and wrapping it back over when we get to 24. Let's see. So right here, character movement, add impulse. This is what you'll use basically. Add impulse is an instantaneous force, usually applied once. If you want to continually apply forces each frame, use add force. So add impulse is fire off something and it just goes. So basically you hit a button, a bomb explodes, and that's an impulse. If you want to continually move something, that's when you'd use the add force right here. And it's basically going to just continually push something, basically. So this would be kind of like hitting something, and then something happens, and this would be like pushing something. So you use one of these two based on what you want to happen on your 2D jetpack. You'll just use one of those. And then, yeah, then again, add this on the z-axis, basically. Or if they're facing left or right, maybe you don't want to go straight up. But you'll just add it on whatever axis you want. And then make sure in the character movement component, you've locked the axis that you don't want to go back and forth on. That's basically how the 2D one works. You're just locking an axis. Okay, so let me wrap this up. This is our generic time of day system. Again, all it does is add every second to our number. Once that number hits 20, technically 24, it subtracts 24 and goes back to 0. So 24 and 0 are the same. Super simple, super stupid time of day system. None of that matters. All that matters for that one is we are somehow getting a current time of day and then doing something with that time of the day. Basically passing that off to the people who listen to us, either by doing the Blueprint interface version or by doing the event dispatcher version. And that's it. It takes a little getting used to. Hopefully this is a basic enough information. I do have a video on event dispatchers, and Zach did a video on the official Unreal Engine Unreal Engine channel for Blueprint communication, of which event dispatchers are in there. As you saw, 3 different ways of doing this. All 3 of them gave us a result. Just simply pick the one that you want to use appropriately. Think about performance. That's about the biggest one. Something where you're... So this is something to keep in mind here. In terms of, we basically went from the worst performance to better performance doing it this way. Our time of change right here, since this is technically called every time our time changes and told to anybody who listens to it, if we had 100 people listening to this one, but they only cared about it at certain times, we're still going to have 100 things that gets notified every time we do this. By doing this with our sunset and sunrise section, even though we do the math in here every time, we're then only notifying the appropriate people as needed. So we've gone from, 100 every time to maybe every other time 100, or 50 of them at once every 6 times, and then another 50 of them at once every 18 times. So we've broken up our workload by doing it in here once. Because if you think about it, this code would technically execute on every item you notified, so they could figure out when their sunrise and sunset was. By moving it into here, we're only executing it once, and then passing that information along. So that is something to think about in terms of not necessarily optimizing the code, but when you're duplicating stuff, that's the best way of doing it. Technically, this code was only in one blueprint, but since we used it multiple times, in our example 4 times, we had that code duplicated 4 times. We moved it to here, boom, we now do it once, and we're good to go. Set up a bunch of events as needed, and go from there. Yeah, so that's pretty much going to wrap this up. I'm pretty sure I hit every blueprint. Wait, I know there was a function. Didn't I do a function somewhere? Nope, no functions, just events this time. Okay, so that should be good on that one. That's pretty much going to wrap up the stream for today. About 1 hour and 50 minutes. I appreciate everyone hanging out. I don't have anything planned for... So I did this one. So I'm going to convert this into a concept video and then record that for other people. But I don't have anything planned, again, for Friday's stream. So I'll go back to AI unless something else pops up. So Friday's stream should be roughly 10 o'clock Pacific, roughly 2 hours before now. Anyone has any questions or comments, feel free to leave them on the stream. Once it's done, it'll pop up on YouTube in a couple hours. You can always watch me on YouTube or Twitch or Beam. You can contact me on Twitter. You can email me. That information is in the About page on YouTube. You can go to this fantastically disorganized blueprint thing that I really need to work on. If you want to request something specific and it's not on the stream, just add it as a comment. I plan on cleaning this up at some point. It's way too big. I need to fix. I don't think I should have 165 items queued up right now. I need to work on that. But that's another place to get a hold of me. Yep, ask questions. I do blueprints, obviously. I appreciate everyone hanging out again. Everyone have a good rest of their day for however long it is. I'm going to go ahead and mute the microphone. It'll last about 30 seconds, and then the stream should end. That way I don't just all of a sudden disappear. Everyone, again, have a good rest of their day.